Yeah, regular grammar and regular language. So already we know what is grammar. Grammar is used to describe the language, as well as we can use a production rule, we can create the language. Okay. And it is also one type of formal grammar that is used to describe the regular language. We are having different type of grammar also. It comes under type 3. It is a simplest type of grammars in the Chomsky hierarchy. So type 0, 1, 2, 3, 4 we are having, type 0, 1, 2, 3, totally 4 types of grammar. It comes under type 3. Okay. Here we are having two types, right linear grammar and left linear grammar. And we'll see the example. Here this is main characteristics of finite, that is regular grammar. It is a finite memory. We can handle only finite memory. So generally we are using here finite automations, and also it is a symbol structure. We can use only for symbol pattern matching concept, and also it support for finite automations. The default it's we are having the two types, deterministic as well as non-deterministic. Okay, so we are going to see the example. Generally we are having this grammar rules A tends to alpha. So here the alpha belongs to non-terminal and the alpha belongs to terminal, you know. Here we are having two types, right left linear as well as right linear. Okay, left linear and right linear. Okay, we are having this grammar like this. A tends to either small letter or A tends to A, A. Okay, and A tends to small letters or A tends to E, A. Okay, so this is called right linear. This is called left linear. Why? So here in right hand side, that is a right end position at most, right end. Okay, this is right end position, at most one non-terminal. That is called right linear. Here in this production rules, leftmost we are having only at most one non-terminal. Okay, at most. This is important point here. So this is the example for left linear as well as right linear. Okay, so we'll see one example, then we can understand what is left linear as well as right linear. So now we are going to write the production rule for generating the word computer using regular grammar. So what is actually the input here? Yeah, C O M P U T E R. Okay. So totally 8 characters. So using these 8 characters, we can generate 8 factorial possibilities of words. Okay. Not only the computer, we can generate 8 factorial combination of these words from these characters. Okay. For example, compute, put, then anything. Okay, so like that we will generate possibilities of 8 factorial possibilities of words. Suppose repetition may be any occurrence, any characters may be repeatedly occurs, based upon this it will be reduced. Okay, suppose you are going to generate the word. Here how many characters? 1, 2, 3, 4, 5. That is 5 factorial divided by p is repeatedly occurs, so that is a 2 times its occurrence. These possibilities we can generate the word. Okay, so like that we are going to write the general rules for generating the words from the alphabet, that is alphabet, COMPUTER. Okay, Simply I'm writing one production rule for this. Yeah. I am starting with yes. So it starts with computer. That is C we need. That's why I'm giving the C. S1. So S1 tends to O S2. S S2 tends to M S3. S3 tends to P S4. S4 tends to U S5. S5 tends to T S6. S6 tends to E S7. So S7 tends to R. Okay. So this is right linear grammar because right end we are having non-terminal. Okay. This is called a right linear grammar. So once we ensure whether this production rule is generate the computer or not. Okay. So how will you start? Always you can start from the starting protections. Yes. Okay. Yes tends to, we are having the two characters, yes, to C as well as S1, so just to write like this, S1. Again, the non-terminal S1 generate 0, then S2. Sorry, not 0, O. So S2 tends to M, S3. Then S3 tends to P, S4. Then S4 tends to U, S5. Then S5 tends to T, S6. S6 tends to E, E7. So S7 tends to R finally. So now you check, you are getting this computer. Yeah. You can check, is it possible to generate any other words from this production rules? Yeah, S tends to always see S1, so it will start from again 0 S2. So instead of S2 we are putting M S1. So definitely this production rules only support for computer alone, but we need to write the generalized rule for generating all the characters, all the combinations. Suppose you want to generate the put words or compute or comp, whatever it is defined or derived from this, we will write the generalized rule. So we will check how will you write the generalized rule for, yeah. So here instead of S1 we can write small letter, we can always use, yeah, 0 yes, S tends to or 0 C, oh yes, so S tends to M yes, so S tends to P S, S tends to U S, S tends to P S, S tends to E S, S tends to R means we can generate any combination. For example, S tends to, yeah, C, then S tends to, you can write anything. For example, M S tends to C S, then instead of S you can write R also. So this may be CR. And S tends to C R, yes, S tends to P, yes, n tends to u, s tends to, suppose you are putting here s tends to epsilon means, yeah, we are generating this word CP. Okay. So here in this rule, we always start with C only. Okay. So we make it one more SS also, or S tends to only one S also. Sorry, E also. So like that we have to think and write which is applicable for all the words what are the input given from you. Okay. So like that we can write the generalized rule for it will be applicable for generating all words. Okay. So this is a way of writing left linear as well as right linear. So instead of right linear, we can start from S tends to S, A also. S tends to S, C. Then S tends to O also. So like that we can write. So this is way of writing regular grammar. Here whatever the language derived by this grammar, we can say it is called a regular language. This regular language only accepted by the finite state machine, that is a finite automata, either non-deterministic as well as deterministic. Thank you.